Okay, so again, welcome to the lesson. Let's start. It's going to be a bit informal today, but last lesson for this session. Just chip in if you want to discuss stuff. I'm going over the introductory ones quite fast now. 12th lesson, so we know the drill. So today's lesson was kind of twofold. Basically, completion of the Rossmann exercise, and then part two, like the last third, basically of the lesson, the ethical discussion that you also did in the recent deep learning one. So I didn't prepare anything for that, but we can surely discuss your opinion on that, and it's really important, I guess. So if you don't mind, I just jump right in and then we'll see where we go. So basically, I kind of scribbled together a couple of points from the lesson. So basically, there was data preparation going on. Basically, he was discussing how to transform columns and basically discussed efficiency. So, not sure how familiar you guys are with NumPy or Python, scientific Python kind of in general, but you can do the apply in pandas, and then you basically specify the axis and you can do any transformation you want and you apply that, but that's pretty slow because it's not optimized, it's not vectorized. So in his exercise, he actually did a NumPy application. So NumPy is heaps faster. So he said something like a factor of 300, which I found pretty amazing. And basically he did a lambda expression as well. So we can discuss lambdas. Lambdas are basically anonymous functions. So you don't have to specify with def a function, but you can do a inline function definition. I don't know if we should discuss that. That's kind of a language feature. It's kind of handy. But whenever your function gets more complicated, it makes sense to just define a proper function. Also, if you want to test your code, you have to have an explicit function. And with lambdas, you kind of hide that from any proper testing, I guess. And then he kind of goes a bit into why pandas is great for time series data. That's kind of historic because it was designed originally for time series data. So there's a lot of functionality you can use. And also like a lot of these time column features like day of the week, if it's a holiday, there's a lot of this functionality baked into pandas, which is really good. And then he shows a bit of feature engineering that you basically also may want to account for events in your time series. So basically, if there's an event happening in your time series, you might want to prepare extra columns that tell you how many days prior to an event you are or post an event. And he's doing that with a custom function where it's basically checking for an event, and then for the row afterwards, he's incrementing this, or the row prior, he's decrementing that. So you get extra features. And in theory, a deep neural network should learn this kind of functionality as well, but he's reasoning that you can help it quite a bit and make it much more efficient to find these kind of relationships. If you want to discuss stuff, just stop me, unmute yourself and discuss stuff. Otherwise, I just keep going and we can discuss things later as well. So another feature.
I have a kind of question, but I realize that it's kind of, it might be actually too broad, but
bring it on.
I'm trying to understand time series for quite a while now and understand that it's kind of an autoregressive process, basically using somehow regressing like timestamps on stamps that were before. But if you could maybe elaborate a little bit on it. I also know there's ARIMA models and exponential smoothing and so on, but I really don't know how that stuff works.
Well, it's kind of a discipline by itself, and we are here just using really simple features. We don't really do full time series analysis like ARIMA or whatever. So with these kind of components, you can basically break down the signals within your time series. So you can try to identify like a seasonal trend or weekly trends and stuff like that. And if you've seen this new library from I think it's Facebook.
Yes, Profit. I know Profit. I was at a conference where we talked about this, and basically everything is automated. But what I don't like then about this is that it takes away your personal,
it's kind of
quote unquote understanding.
That's right. I mean, I'm not really an expert on time series analysis, but basically what you do is you decompose the signal. Basically, you try to find repetitive signals within this time series, and that's also what this Facebook library does, right? So if you just apply it, it'll pull out the seasonal trends and the weekly trends and stuff like that. And here, I guess we just kind of parameterize or give the model extra columns that it can find or detect signals in, like the whole procdf thing and the whole the add date part or add date or whatever it's called. I'm already in version 1.0 functions, but that's basically the whole point, is to give extra columns, extra features that can contain a signal, and a neural net will just pick up because it just detects any signals it finds useful. So that's also something he's discussing quite a bit, that it's like totally in contrast to the traditional statistical models where you want to restrict your features to the minimum set. And here it's basically you don't care how many features you use. I mean, you don't want to do features that have no value at all, but in principle, the more features, the better, and you keep everything under control with regularization, dropouts, and stuff like that. Whereas in the traditional modeling, you really want to keep the features under control, because otherwise you can't explain what's going on. So, but for proper time series analysis, that's not covered here, and that's
no problem. Yeah, that's right. And by features you mean predictors, right?
Yeah, columns, basically. Features or columns or covariates. Yeah, and that's done. I mean, we haven't seen that in the last couple of lessons, I think, but that's the add date part, where it's adding like day of the week, day of the month. Is it end of the quarter? Is it a weekday, such and such? Is it a holiday? Is it a public holiday? And stuff like that. And here in this episode, he's basically adding a couple of extra ones, basically like encoding these events, basically. Is it a couple of days prior to a promotion, or is it like 5 days after promotion, or prior to a holiday? Because the reasoning makes sense, right? So if you're predicting your sales in a grocery store, people kind of stock up after before holidays, so that's probably useful.
Right. Seasonality would make perfect sense there, I think.
Yeah, and also like these kind of ramp up or cool down kind of variables, right? So if it's like 3 days prior to a big holiday, people might stock up and buy in advance, stuff like that. Yeah, and later on after holidays they need to refill the fridge, so kind of makes sense to keep track of that, not only at the exact date when a holiday is happening, but also like the build up towards that. Right.
I recently was at PyCon in Germany, and they did a similar thing. I was at a talk where the company Blue Yonder tried to predict like not the sales, but the need of US retailers using sort of a very, like you just said, like you just alluded to, very complex model indeed, where they predicted when and at which time and the amount of meat that a retail store would actually need.
Okay.
It was fairly interesting. I think it is a similar model like the Rossmann Kaggle challenge that you just alluded to.
Was that in Karlsruhe?
I know you were in Karlsruhe too.
But I haven't been to this talk.
No, yeah, it was late in the evening. I think it was at 3 at night or something. Very, very weird thing. Yeah.
Okay. Cool. Right. What else is on this slide? Okay, zip functions. I mean, I don't know. With zip, basically, you can tuple together like elements of different lists or columns or whatever, and iterate over them. And I didn't know that. I know that iteros in pandas is kind of slow, but was kind of astonished the speed up he gets when he actually pulls out individual columns and zips over them instead of doing the iter rows. So that was something for me to keep in mind for sure, because I'm using iter rows quite often. So that apparently is much more, like much faster. And then he goes a bit into, again, time series functions, rolling functions. That's basically if you want to compute something like a median, a mean, or a min-max on a certain subset of your time series. So basically, classically, if you want to smooth like a really jagged curve, you might have like a moving average over a certain window, and then you can easily apply that. That's all built in pandas, and you can also specify, that's kind of important, how you want to handle start and end of your time series, because if you don't account for that with a parameter, basically you'll get a couple of nans within before your actual data starts. Because if you think about it, if you have like if you want to take the mean of 7 days and you start with the first day, then you're missing like the prior 6 days, obviously. So you can account for that and specify a min value, and then you can say, okay, min equals 1, then it means, okay, if you have one value within this window, that's still good, and just do that then. And that's important, otherwise you're shrinking your data and you mess up your table if you don't account for that. And then it's important as well that you think about where you're at and if you're predicting into the future, because obviously if you're at point T and that's the mean of your window, then you would have 3 days to the right that point into the future, and that doesn't make sense if you don't know the data. So you need to make sure that you only like take 7 days prior to your actual day, stuff like that. So you can configure all of that, and he shows that a bit. Right. Then he goes a bit into embeddings. That looks like missing a D. So basically, he's giving a bit of an intuition how big they should be, right? So if you have normal numerical columns, you can just put them into your neural net as this. You probably need to normalize them to even out the kind of gradient kind of for all the features, but you can plug them in as is. But for categorical values, you want to create embeddings. And so there's a couple of rule of thumb that he's kind of proposing. So for instance, for any language tasks, there's like this rule of thumb of, I thought, like 300 spots, but he's giving 600, so quite big embedding vectors, because there's a lot of hidden kind of meaning, or can be a lot of hidden meaning and nuance being conveyed in certain words. So it's to capture all of that, you need kind of big embedding vectors. Whereas categorical data, in our example, you can get away with quite a lot smaller ones. And here's this kind of rule of thumb that you basically take half of your feature space and cap it at 50. So that's this formula, right? So as a rule of thumb, if you have like 7 weekdays, you can get away with like 4 embedding elements in your vector. And if you have like something really big, you might limit it to 50. And that's purely his kind of experience. So there's no proper way of actually deriving these numbers. It's kind of rule of thumb and his experience, and kind of makes sense. And in general, I mean, you don't want to go too big, because it's wasted memory, basically. If you compute stuff and have big embeddings, you're basically using up your graphic card's memory. And if you don't have to use so big embeddings, make smaller ones, right? But it's kind of a neat thing, and apparently, I mean, if it works, it's a good starting point. But he also mentions that basically, if he finds that it's not really needed, I'm not sure how you would actually see that, but if you find that some embedding doesn't really help you much, you can always, in the second iteration, shrink it, make it smaller, and save some memory. Then next point would be basically that you really have to be sure that you carry over your decisions, like how you use categorical variables and how you normalize and how you embed stuff between your data sets, right? So if you design that for your training data set, you have to make sure that you carry over the same embedding space and the same normalization for numerical data and the same categories to your validation or test data. Otherwise, you're just getting nowhere. So you have to make sure that if you normalize, that you take the normalization mean and standard deviation also to the validation or testing data sets. You can't derive it independently. That's causing chaos. Okay. That's already, I guess, all for the Rossmann thing. I'm not sure if I missed anything about that. And then he goes into kind of a mini review, but it's really super short. So it's basically, I managed to put it on one slide. I'm not sure if I missed something, but basically it's just, again, going over, okay, there were two kind of methods featured, right? Trees and random forests and basically simple neural nets. And trees can be used together with bagging to form random forests, or they're used with boosting, which is probably more common in applications you see on Kaggle because they're a bit more powerful, it seems. And then you get gradient boosting machines. And then he briefly goes over a couple of the features again, why you use them or why they're good and robust. So basically with random forests, you can just take ordinals. You don't have to think about one-hot encoding them because eventually the random forest will just split at the appropriate place. And it doesn't really matter if it's a zip code that doesn't really follow a proper order. You might just need more split points to really home in. But in principle, it doesn't really matter. And random forests also don't need to be normalized because they just care about the order of a variable and not about the magnitudes. And something I found quite intriguing, and I wanted to ask if anyone actually explored that, is to use these this kind of exploratory techniques we used with the random forest to actually check out your neural nets. Like if anyone has used partial dependency plots or stuff like that on neural nets, because I don't know, for me, all these tools were kind of linked to random forests, and I never really thought about using them with neural nets. Has anyone done anything about that? Explored that? Played around? No? Well, me neither. I thought I can steal some inspiration from someone, but it sounds kind of interesting, and I didn't really explore that yet. And I think that was pretty much the wrap up for the lessons. And then he goes into ethics in machine learning and AI, and didn't prepare anything about that because we kind of had this as kind of a featured talk, and also like in the deep learning and machine learning sessions, but we can surely discuss how you feel about that and how you think basically how to fix that. That's something I'm not really sure about. I mean, it's kind of obvious that a lot of the data is biased, but how to effectively actually unbias your training data. I mean, that's for me the big thing, like with the biased data sets that people of color are underrepresented in a lot of these data sets. It's kind of hard, at least if you don't really have a huge budget, how you would combat that, I guess. So not sure. I mean, it's probably for the big firms or the big applications where it's easiest to fix. It's probably for us just to be aware that these biases exist and that you really have to think about the consequences if you apply this stuff in the wild, and how to communicate that there might be biases in there and that you have some kind of checks in place once it's released, how to actually verify or kind of put it back in if you find errors and problems, I guess.
What are the problems for me is how to control ownership. We can't copyright or patent anything that we do. In fact, most of what we do, if we use transfer learning, we're actually using somebody else's model. And so
that's true.
From an ethical standpoint,
you mean who's responsible for biased model?
You have no idea when someone's going to take your work and use it as a transfer to do something horrible. There's no control, or there's no way to guess. As they say in Murphy's Law, never underestimate stupidity, but then also never underestimate how devious people could be.
I think that there's going to be
you don't have visibility.
Sorry, I'm sorry, I didn't mean to. James, go ahead.
Yeah, you just don't have the visibility to be able to see that you do something, someone else takes that and does something horrible with it. You don't.
Well, I heard that they're working on ways to encrypt your model so that you can have a model that other people can use, but they can't see the inside of it. They can't get at it because you have it encrypted in some way. I think there are some people that are working on that.
I don't see how that would help, because the whole concept of transfer knowledge is that it's a black box and you don't care. You only know, this is I'm a model that has gone through 1 million images and understands, I'm 1,000 different things. That's all you need to know, and you just add on top of it. And that's
but then I would argue that it's kind of your responsibility, like if you use something and you're not sure if it's biased, to actually make proper checks, right? Because then it's your kind of thing, and if you release it into the wild, you're on the hook, I guess. Your modifications, which is tricky. I mean, of course, because if they can train some kind of image model on like thousands of classes, you don't really have the capacity. But then if you kind of tune it to your application, I guess, then you have to validate it again.
Oh, we're running ethically in the same position a gun manufacturer has. He manufactures a gun. Somebody else manufactures ammunition, and then some guy uses that to go rob a store and they shoot somebody. Is there any responsibility? And we don't know, unlike a firearm where they know, they're familiar with how it can be misused. We have no idea how it could be misused. Anything that we put out there or anybody puts out there for us to use, there's no visibility at all as to what someone might do with that.
Yeah, sure, but
unethically.
I would argue, it's kind of similar. Well, not really. That's probably for all kind of code, right? Code could be you can do anything. It's kind of not physical in the way, and therefore you can.
It's the same thing as if somebody bought a car from you and then went out and got drunk and ran over people. There's no control you have over it, and nor should you worry about it. You sold them the car, and it's up to them what they do with it after they bought it.
Exactly. So the only ethical part that I think people can do is, if you're given an opportunity to do something that is unethical, that you don't do it. And if anything, you broadcast it. Hey, IBM, they wanted me to do this, or Google wanted me to do that, But aside from something, you're being asked to do something unethical, you really don't have any responsibility outside of that. Though it would be useful to give some thought to it. How could this be misused? And that might be your criteria for publishing or not. But still, that's such a small view of the potential misuse of anything.
Yeah, like for me, it would be at the end, right? If you like say you're producing anything where you can track objects, I mean, this methodology is pretty generic, but if your job is actually to do like this total surveillance like they have in China now, that you actually track individuals like all over the place, and which is obviously like a big privacy issue, then this kind of concrete application, that's where you have to decide if you can actually do that, like with yourself, right? But to kind of restrict, if you want to put out some algorithms that can do object tracking, it's this kind of debate. Like it's not per se a weapon. Like the actual application will turn it into one, and then you have to really decide, okay, can you actually stand behind this application, or do you say, okay, it's not?
Yeah, so there are some cases where it's really clear that you're working on something that has an immediate application to something nasty, and you're aware of that, and so you have to be careful about it, or refuse to work on it, or safeguard your product from being misused. But it can be much more innocent than that. For example, suppose you're working for a company which has this great new education product where they can teach you how to code or something like that, and then they want to market it, and they're just blindly maximizing their profits, so they only show the ads to people who have money or something like that, right? And so people who don't have money don't get shown these ads, and therefore all this potential talent gets bypassed. That's just a much simpler example of bias. And I don't know what you can do about that. I mean, you're working for the company, and they told you to maximize their ad revenue, and so what can you do?
Yeah, I mean, these runaway feedback loops that he told, like also about Facebook, like the Facebook thing in Africa, and also these jurisdictional models for sentencing. That stuff is really scary. I mean, that you basically have this kind of self-fulfilling prophecy that you kind of, I'm not sure how to break that. I mean, for kind of image classification, this kind of stuff, okay, you need some kind of a balanced data set, and then you kind of make a fair kind of model, right? But for these kind of feedback loops that kind of enforce itself, that's really hard to, I don't know. Yeah. These examples, when presented, they were really clear and really striking, actually pretty
Probably the major problem as a human being is that we have confirmation bias. And so if we hear something that confirms our view of the world, we remember it, but if it contradicts it, we forget it, Yeah. Or regardless of the value of our view on something. And so, like when someone's doing business, B2B as an example, instead of B2C, there could be targeting only people, only, say, companies that only earn X amount of dollars. In doing that, there's an inherent bias that people of diversity will not be engaged, because predominantly the people in the United States are not of color. It's primarily white is the people that you'll be dealing with. So there are confirmation biases as well. We sell to this segment of the market, and that just happens to be a lot of white people.
Yeah, sure. It's really tricky.
But wasn't there recently even a law, I think, either in Europe or in the US, that stated that you have a right to, at least with these very high stakes sort of judiciary algorithms, that you have a right to get explained to them how they came to their conclusion or how they made their decision? I mean, that could be kind of a way out for people if they had that right to basically go to whatever institution that is discriminative against them and say, okay, how did you arrive to this? How did you come to this conclusion or to this decision?
I think that's in the European GDPR kind of regulation.
Yes.
Yeah,
okay.
Which is really interesting because that gets back to what Christian was saying about the method. Christian, you were saying you're interested in methods of examining neural networks, to, like the way you get importance for random forest. Random forest gives you importances for all of its variables, and so you can track down decisions, how the decisions were made, and I think they're developing techniques like this for neural networks as well, so that you can see exactly how this decision was made, and that's a really interesting field, I think.
Yeah, but I mean, does anyone know anything specific about this European regulation? Because I know this kind of phrasing of it, but it's like totally impossible at the moment. I mean,
Yeah.
Like it's kind of super vaguely formulated. Basically, you should do, but there's no way how to do that, and it's probably the only fact it has that it kind of would block deep neural networks in being applied in Europe in critical decision making. That's kind of the only effect I can see until such tools exist. But I don't see that they show a way how, like the hard requirements, how that would work out, and that's something. I guess in contrast to like the examples from the US, where it's already stuff like that is used in predictive policing or in the sentencing stuff, right? If that's a neural network, that would be like would totally violate this kind of regulation guideline. But I have no idea. It's probably not common yet in Europe, so that's why it can still be drafted like this, because it's not actually in use. In the US, it would totally violate these tools, right? Or the other way around, these tools would violate these kind of requirements.
Yeah, well, to me, if I had a company and I had a complaint, that complaint would go to marketing. And marketing could come up with any kind of justification for, oh, this is why we do that. And this is why it's not biased, even though the effect of it is a bias.
Mm. I mean, we have something.
That's a moot point, I would think.
Yeah, I mean, the only widespread application in Germany for the moment I would think of is your kind of credit scoring thing, right? Where we have the right to actually ask what's in our record, but they still don't have to show the algorithm that gives your kind of score, because that's a trade secret. And then
oh, really? Because the United States, I don't think that's the case. We have 3 major companies that do that, and for free, at least once a year or every couple of years, you can get a specific thing, a written showing what your score is and the things against you, and you can challenge anyone.
Yeah, I mean, I haven't done that, but I think you can, as well in Germany, do it once a year, and they'll show you what the records are that they have of you. But that goes into some dark black magic model, and you still don't really know why, like your mobile phone plan is denied or whatever in the end, because the actual algorithm is not public. So you can correct obviously bad data in there, but you can't really say if they discriminate against you because you're, I don't know, living somewhere where a lot of stuff happens.
I would agree that isn't shared, but that's only the criteria. But there's a real strong, in the United States, there's a strong correlation between what you have in your record and your score.
Okay, so it's kind of a connection. Okay, yeah, I guess it's the same here, but it's still that, yeah, it's still, it has a lot of impact. Probably more so in the US, but you can't really fully digest how they derive their conclusion.
Well, only if like you don't have anything in your record and you're only getting like United States is 600 or something, when you should be at 700 or something. To my knowledge, no one in the United States are making those claims, because the only thing one could do that, I remember reading a long time ago, I don't know if it's the same, but in the United States, if you want to have over 600 on your credit score, all you have to do is pay all your bills on time for 2 years. That's it.
Okay.
You know, now to go up to the 700s, I don't know what the criteria is, but just to get up to the 600s.
Okay.
Just
Yeah,
bills.
I don't know. I'm not sure if they actually publish their criteria. You can, for sure, you can check if there's like bad information in there, and there often is, which is really scary. That they have really, like, almost for every person, they have a record, but quite often there's really outdated and wrong data in there, and you don't know if you don't check. And apparently these kind of models are super simplistic too. And if you like continue this kind of thinking, if you derive like really big models that might be applied at large scale, then that gets super complicated and super hard to really evaluate, I guess, if they don't really share the actual model and the actual criteria in there, and even if they can't explain.
Well, now, you know, I'm talking, I may have done this like 10 years ago, but there was a site and I could go when they had more than a half dozen criteria, and it turns out the effect of that is if you paid all your bills on time for 2 years, your credit rating would go over 600. It was 630 or something, or 680 or whatever.
Okay.
I don't remember what it was, but I was surprised that that's all it took.
Okay.
But that's the United States, and that was, I think that was all of them, though it may have only been like one of the providers. In Germany, is there only one authority to do that, or like United States, we have several?
Well, effectively, it's one. There's like they are just the absolute biggest, and they dominate the market. And there's like a second one, I think, but it's basically, if you want to get like even a mobile phone contract or anything, you'll always be checked on this kind of record.
Mm.
I don't know. Yeah, I haven't had a problem yet, but it was in the news recently. Anyone else wants to chip in for this kind of a topic? I mean, I think it's super interesting and super hard to solve as well. I mean, it's especially these kind of examples, like when you have these kind of runaway feedback loops, it's kind of crazy to think about that. I guess, I'm not sure if that was his advice in the end, but basically think about it. If you would be affected, like, is that kind of a reasonable application that you would want to be out in the wild, and kind of think about if you can actually stand behind that and not just be the anonymous techie that just does some code, right? Try to think about it.
For me, I think it would suck that you create something that works really great and everybody's happy, and then somebody does something horrible with it, and there's, and it's a sad excuse to come and say, well, I didn't know that was going to happen or could happen.
Yeah.
It's kind of lame, and who knows what the ultimate effect would be. Maybe, we do something and Skynet is born. What kind of responsibility can you take for that?
Yeah, I guess it's more like whenever it's kind of more concrete, right? If something is asked for you and you obviously feel, okay, that's going to have some bad consequences, and then you can't basically say, well, I'm just programming this, so I'm not applying it. But if it's obviously like, I don't know, mass surveillance and could ruin people's life, and it's kind of obvious, and you're just saying, okay, I'm just an engineer, and then it's kind of a direct consequence you have to take in, right? Whereas if you design something and it can be misused in a totally unknown fashion later on, that might happen with all kinds of discoveries.
I remember on my first COBOL class, and the first day the instructor said, programs live forever. And so wouldn't it be really bad that somebody came up to you and said, when you wrote this program, how come you chose to do that? Because a programmer makes a lot of arbitrary decisions. Mm-hmm. Well, we're in the same situation too. So at least from an ethical standpoint, before you put it out into the wild, you should at least give some thought to the ethics and how it might be misused. So if sometime later they said, why did you do that? And you say, well, this is why I did it. At least you have an answer.
Yeah, would be good. Yeah. Anyone else?
Yeah, so at the moment, I think in Germany, they have this thing called MDG. So like medical device regulations. I remember taking a course last semester in my regulatory affairs. So when you have software that has direct application in healthcare, then there are regulations that are put in place. Like you have to give a documentation to whatever the software has to do with healthcare. So I think right now it's already implemented. Before you produce, then all these are up to the checks.
Yeah, for sure. I mean, in medical fields, like the checks are really thorough, at least for drug trials or for anything like health related. There's like multiple layers of really thorough kind of checks, right? I mean, we had a local meetup here where people from pharmacy basically explained like how long an actual drug takes from being designed to the market. It's like $1 billion of money being spent, and a lot of trials, like internal trials, bigger trials, and a lot of double checking. And then once it's released, it's still checked. Like it's still monitored if there's an issue, right? And that might also be kind of necessary for if you have like this really big application, like if Google puts something big out, right? They have the means probably to also check afterwards, like if it's in the wild, if it's fair, and then maybe can step in. It's probably really hard though. I mean,
Yeah.
for a lot of stuff, like I would assume like a couple of people or small companies doing this stuff, that would be totally out of their scope. They could probably kind of control in-house what's going on and make sure that their training data is kind of solid, and think about stuff which are edge cases, but like to have this strong kind of pipeline of checks, that would be massive. Yeah, it's probably a totally different infrastructure and companies needed for that. But maybe it's maybe for some stuff, like I was totally shocked about this example from this judges in the US, that they get some software and the software tells them, okay, this guy stays in jail or goes on parole. That's to me, it's kind of insane, but it's also a different jurisdiction, so that I can't really imagine that it's applied in our kind of legal system. But it's kind of scary that you have these black box systems and no supervision there, or little. But it's right. I mean, in medical disciplines, it's really thorough, because people's lives are like directly affected by that. And there's a direct feedback loop, right? If you do mess it up, yeah, people will die, and that's really obvious. And it's probably also for the autonomous cars, right? When you have self-driving cars and you have like a direct lethal impact if something goes wrong, then it's much more direct regulations. Whereas if it's this kind of unspecified kind of general effects it might have on people's lives, it's really harder to regulate, or it's not as...
Well, there's the ethical problem of you're about to get into an accident, and do you kill
exactly.
one person or you kill 20 people?
Exactly.
You know?
Yeah.
And the one child that you're thinking about might be an Einstein. You don't know that.
Yeah. That's tricky. I mean, I guess it's going to be like a whole field in itself, this kind of ethics in these kind of models that you have to have.
There's a whole discipline in philosophy about
dedicated people doing that, yeah, for sure.
Mm-hmm.
Also, I don't know if you've heard I think it was a podcast recently from Sam about like this statistical uncertainty and basically accountability. That was interesting as well, was from Neurips. I think there was a short interview, not about ethics per se, but more like, okay, explainability, and it was interesting, but not really solving the issue.
Well, one thing that's going on, in fact, we're kind of a symbol of that, is, and I remember being warned about this 50 years ago, that we were becoming more like tribes, and we're beginning to see that. You know, the internet, if anything, is an infrastructure for that, where people could be part of a tribe that might span the whole globe now. And so you know, the confirmation bias, if you have a certain bias and somebody comes up a website that supports that, other people grow. And so at least in loosely a connected tribal thinking now. That's really more going on than anything. And it's been my observation socially that tribes affect the individual members more than any other kind of social structure. And so even what we're doing, we have a tribe. This is a tribe.
Yeah, it's true.
You know, a loosely connected one. And so we have values. We have all of the on the pinnacles of a small little society, values and experience and so forth.
Right. Yes.
On a related subject, I was just curious if any of you had come across the Montreal Declaration for Responsible AI, and whether you think,
Nicholas, you're kind of breaking up a bit. It's can't really hear you.
Yeah, maybe turn off the video so that you're just getting audio. That might.
Not really.
No, he must be with Comcast, because I have Comcast, and every once in a while.
Or Nicholas, just use the chat. I mean, that would also be a possibility.
Yeah. Yeah, sorry. Not sure where you are, but it's not well connected.
Well, we'll stand up and wave your hand over your head. That won't help, but maybe it's good exercise.
Okay, he's in the chat. He was wondering if any is familiar with the Montreal Declaration of Responsible AI. I think I've
heard of it, but was that part of what Jeremy was doing in Montreal? Or did that come up? Does anyone know?
And whether there was potential for this to be adopted by industry in addition to researchers. I'm not familiar with it, but I heard about it. I don't know if anyone is familiar.
I only vaguely heard about it, but I haven't read anything on it. I don't know what it's about.
Yeah.
So I haven't heard about it even.
Okay.
First time that is mentioned in the chat.
I think there was some kind of a draft or kind of document of researchers that they kind of like, I think it was going on for a bit longer already. There was kind of an ethics consortia where they discussed ethics of robotics and AI and if there's kind of a common understanding like what fair and reasonable research there is. But I think he's right. I think there was more about kind of based on researchers. But I don't really have proper knowledge about that.
Well, you know, it's like, in terms of this technology, it's like I'm giving a 2-year-old a loaded firearm. I mean, we really don't know what we're doing, and we have no idea what the implications of what we're doing are going to be. We can suspect, you know, but only in the most global sense. You know, like a 2-year-old child knows when he pulls on the trigger, there'll be a big bang. And that's about where we are with it.
Right.
I mean, with machine learning and AI, it's with every technology. Basically, you get a tool, and we as humans have to decide what we are going to do with this tool. So, I mean, on the plus side, I mean, you are all aware of the amazing applications that happen in biomedicine, for example, with personalized medicine and so on. That's just awesome. If you have next generation sequencing and microarrays and so on, and you can screen out certain cancer patients for which you can get very specific drug. I mean, that is better than giving generic chemotherapy. And this is where I see an amazing application of this technology for the good of humanity. Or think about if you were in like sub-Saharan Africa or some resource limited setting where you immediately can replace a dermatologist and say, okay, this person has skin cancer via a machine learning algorithm. I think there are a lot of examples where the benefits are quite clear to me.
I mean, what I think is that like what makes this kind of special is the rapid pace of development, right? I mean, if you think about it, the turnover of new models and new applications, it's like super fast. Like if you compare it to a traditional industry, a research field where it's kind of progressing, and some are faster or some have more severe consequences, but like the application and also that it's like backed by huge corporations, right? Like that huge corporations have a lot of funds they could funnel into research into this, and then can push like really rapidly into certain direction. And therefore it's probably more critical here to get something up and common understanding really quick because there's so much going on. That's what I could think of, right? Well,
my approach is, again, the 2-year-old analogy. It's like, you know, what happens when you give a 2-year-old a hammer. That child.
Yeah, but you probably can't really stop it, right? You can't not give it out because it's already out there and there's a lot of benefit in it, and therefore that it's going to be developed. It's probably chasing after the 2-year-old with the hammer already in hand.
Mm-hmm. Yeah.
Okay, so he actually put the link in the chat.
Yes, I'm there too.
Okay.
The declaration. Okay. Come on.
Okay.
Is it in English? Yes, it's in English.
It's probably in French and English, right?
Oh, here we go. Well, if you probably, yeah, you could probably identify it. Okay, blah, 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 blah.
Okay, I'm not sure. Should we like go to the kind of question answering, or should we discuss a bit more here? Anyone interested in discussing more? We still have a couple of minutes. Doesn't really matter.
Oh, this is interesting.
Sure, I am.
I mean,
Well, maybe
otherwise,
we should go there, and then if there's any time left, then go back here. But as I'm looking at this, there's a lot of interesting talking points.
right. So, Nicholas, you want to briefly like plug your Automunch, or I mean, I was basically about just to ask what people are doing afterwards, and basically advertise that we will merge with the deep learning folks. So we wanted to basically continue the meetup, but we don't think like 2 meetups make sense. So we will convene together Saturdays, same time. Also, like this course kind of ended on the neural nets, and kind of makes sense to just join, and not sure how the participation will evolve, but it seems like a couple of guys wants to keep it going. So you don't have to miss out. I think
I can try to.
Okay. Otherwise, we will just link your link as well in the chat, because you're still kind of hard to hear, but you can try. Yeah, but
I wonder how they define autonomy here. Principle number 2. You know, would surveillance be autonomy?
okay, I haven't opened the link.
Yeah. A lot of good talking points. At least get a lively discussion going.
Right. Okay, so Nicholas will present next time because he's just not connected well today. Yeah, so basically the invitation to everyone, there's going to be kind of a loose session going on, obviously, so people will discuss what to do till the Deep Learning 2 session starts. There's also a chat about if anyone is interested to kind of rerun the Deep Learning 1 group, so like for people who missed out on the live course last time. It's expected, I think, to be public in January. I think that everyone can see the new version that just ended on the deep learning stuff. And if that happens, people want to do a study group and rerun that. And the Deep Learning 2 thing should start mid of May. So people that did the previous one kind of will bridge.
March, around 18th.
March, sorry, yeah. We'll kind of keep these meetups going till kind of March, I guess. And if there's the Deep Learning 1 public, then there might be a new study group branching off doing that. And basically, if you want to share anything, just kind of send it to the Slack channel, and we'll, I don't know, give you like 5 to 10 minutes or whatever you need. And you can share that, and otherwise it'll be just loose chatting, I guess, and discussing stuff. There's gonna be a couple of more concrete kind of Kaggle experience stuff going on, but I haven't really followed that too closely, so I'm not sure if they decided on which challenge to do. But otherwise it's just a bit of a campfire, I guess, and everyone can discuss stuff. Right. Anything else anyone wants to bring up? I think the first thing will happen on, I don't know, the 10th of January. We will announce it. I'm not sure.
Luckily, Sam seems to be coordinating that.
Yeah, I mean, we put out basically dates people wanted to take on for hosting. I think I was one of the first actually. So I think we have a bit of a gap in early January. People are just holidaying, I guess. Which is
So thank you, Christopher, for
that's all right.
rather for
Yeah, it was fun.
leading today's meeting.
It's fun.
I'm signing off.
All right, yeah. So people, have a good holiday and see you hopefully next year, right?
Yes.
Yeah.
Okay.
Thanks, everyone.
Bye-bye.
Thanks.
Bye.
Yeah, thank you.